Hello, and welcome to the Pendulum Instruments YouTube channel. In this video, we will discuss what a frequency analyzer is and how it differs from other instruments such as an oscilloscope and a spectrum analyzer. We will also demonstrate use cases in which the unique characteristics of the frequency analyzer make it the preferable choice over the other instruments. We will be focusing mostly on measuring timing parameters, like frequency, period, time intervals, and others. Everyone knows what an oscilloscope is. Oscilloscopes display how a signal's voltage changes over time by recording fragments of signal's waveform. As an additional feature, you can apply algorithms to analyze the waveform and extract such parameters as period, frequency, duty cycle, time intervals, and others. However, the sampling rate in oscilloscopes is a limiting factor for accuracy of such measurements. The lower the sampling rate, the less accurate is the measurement. Additionally, it is often not possible to make long and uninterrupted measurements to observe variation of parameters over time, because of the limited memory to store the samples forming the waveform. Spectrum analyzers represent measured signal as a graph of voltage or power distribution over a range of frequencies. By looking at such a graph, it is possible to see individual components of the signal, estimate signal's bandwidth, and spot distortions. If the signal is a simple sine wave, the peak's position on the horizontal axis will indicate the signal's frequency. Spectrum analyzer usually cannot measure parameters in the time domain, thus measuring duty cycle or time intervals between several signals is not possible. A frequency analyzer is an instrument that represents the next step in the evolution of traditional frequency counters and high-resolution time interval analyzers. Such instruments do not record signal waveform, like oscilloscopes, nor do they show a signal's spectrum. Instead, they show how the selected measurement parameter, whether it is frequency, time interval, or some other, changes over time. Using a built-in or external precise clock, the hardware of the frequency analyzer precisely detects and counts the moments in time when the input signal crosses certain trigger levels. Then the embedded software processes the timestamps and their sequence numbers in real time and uses them to calculate the parameter of interest. Doing this repeatedly at high speed allows observation of the variation of the parameter over time. Such an approach is applicable not only for frequency, but also for many other parameters. Modern frequency analyzers supplement this with multiple independent input channels, performing high-resolution and high-speed gap-free measurements, real-time statistics, interactive graphs, and other features. Since waveforms are not recorded and not stored in memory, it becomes possible to observe the signal parameter variation over a long or even infinite time. Let's see how a simple square wave frequency modulation can look on these three instruments. The oscilloscope displays signals in the time domain, that is voltage versus time. We can see the waveform, but it is difficult to estimate any characteristic of the modulating signal in an easy way. The spectrum analyzer displays signals in the frequency domain, that is voltage versus frequency. We can see that two frequencies are present, but we cannot view the modulating signal, for example, the modulation frequency and the modulation waveform. The frequency analyzers adds the missing part, modulation domain, that is frequency versus time. We can see the modulation signal's waveform, square, and the modulation frequency. No single instrument can replace one or the other, but they all give valuable insight for signal analysis by looking at the same signal from three different perspectives. The new CNT100 series multi-channel frequency analyzers from Pendulum Instruments bring unique new possibilities for analyzing time and frequency-related signal parameters, for research and development, high-precision calibration in metrology, high-speed testing in automated test systems, for control of time and frequency synchronization, and many other applications. CNT100 series frequency analyzers offer simultaneous and independent measurements on multiple channels. One instrument acts as multiple frequency counters in a single box. Ultra-high measurement speed. Functions include measurement of simple parameters, such as frequency and period, as well as more complex parameters, such as pulse widths and edges, time interval error, and others. The measured parameters can be represented in numerous ways, as numbers, in graphical form over time, and as distribution graphs. Ultimate resolution and accuracy. Continuous measurement of intersignal parameters on multiple channels. Continuous phase comparison and time intervals measurement between several signal sources with no need for external signal switching. Capturing repetitive and single events. Remote control and possibility of automation for test systems. To know more, visit Pendulum Instruments website. Thank you for watching. We hope you found this video informative, and we look forward to seeing you in an upcoming video real soon.